Welcome to a mix. This will be a bit of a mail call. I got 4 items from Aliexpress, and then I want to talk ESP, how I set up the environment, because I think I went through the setup rather too quick. I spent more time programming it than doing the actual environment. So we have some items. So our first item in their thing is just some Jst connectors, basically, of a certain size. I was looking for the same size that this Raspberry Pi unit is doing. These guys. So these, what do they call them again? Grove connectors. Really, they're just same JST as what Adafruit uses, just a larger size. So this is what this bag is for. And we don't need that. We'll throw it over there. Then this bag here is a tube of MCP23S17s. So I had the 23O17s on the Apple, and I saw in a forum post that someone said that that wasn't the right one. So we will look at that in a bit. Then my next item in here, these are all ESPs. So they happen to be ESP Room 32s. Okay, so there's 4 of them here. Actually 2 with this, and I think this one here is a different one. This is, I think they're 2 different ones. Yeah, they are. So I'm not 100% sure what the difference is between the 2. So 2 variants of the same thing. And then this bag here contains also an ESP, but a smaller one. So I have this board up there, and I'm not going to bring it down, but it has a spot for one of these boards. Actually, one of each of these boards. You either use the bigger one or the smaller one. So this one here is slightly smaller than this one. So I want to put it on the board. So that's what all this is all about. And they're really cheap, so that's that. Now that Apple, let me find it. Where's that Apple? I know I stuck it around here somewhere. There it is. So here's the Apple, and I'll just put my cord back on the lamp again and move it. There we go. So the problem, they said, was in this chip right here. So let's take the chip off. There we go, like so. And we have this tube of these ones, like so. So pop the tape off the end. Like so. That can go in the trash can. Whoops. Nope, we didn't get all the tape off. Let's try again. It's the only problem when they use Scotch tape on these to do that. Okay, there we go. So that one goes in there. So slide one out. So this, yep, 23S17. So we need notchy that way. Yes, if you're not aware, you gotta get the notch right. The notch is over here. And this is a bit on the fat side, so I happen to have, I put it in here. Where did I put the chip straightener? actually, I'll just put these down here in the bin so I can find where I stuck the chip straightener. Well, I stuck it somewhere, so I'm gonna find it because I want to use it. That's okay. We have in our drawer another one. Yeah. Right here. And boy, I can't aim for the trash can. So this guy here, you stick it in here like so, and it makes your pins nice and straight so that you can get it in here properly. Almost. Okay, so I'm kind of straight. There we go. Okay, so now we have the 23S17. The S stands for SPI. So let us find out. So we're going to need a USB-C. And that's not that. Okay, so let's punch this in. Oh, going to need a terminal program too. So here now, so let's plug this in and see what port we end up on. We end up on okay. Oh, here we are. SBU323 new speed device. Yeah, that's got to be this one. TTY USB 0. So okay. So we want we need some Apple 1 commands. Apple 1 commands. That's fine if we have them. I'm just browsing a website. Nope, that's not a website that works. Let's find this one. Okay. Where's the stuff? That assumes I'm in basic. I need the monitor commands. Nope, not the right one. This is the basic manual. I need Apple 1 monitor commands. Okay. Well, I don't have backslash for the monitor. I have a bracket for the monitor. So according to the back of this, integer basics at E000 command. So E000 run. Oh, I did change prompts. It's just that I'm getting the wrong gobbledygook on the screen. See, I got the change in the prompt. So 10 print hello. Syntax error. This is really good. Okay, we are one step farther. Now we just have to figure out why the prompt and the brackets are all wrong. So I am going to have to go into the code for Arduino and find out why I'm getting this. Right? Let's just reboot the Arduino. So I'm still in BASIC. Let's reboot the Apple. So we got a prompt problem here. So you can see here the slash, according to the manual. Here, let me find it for you. Actually, I just Googled the web page. Wrong browser. Let's find the right browser here. That's that browser. And there we go. So you can see up here in the browser, right where I highlighted. So slash is for the monitor, stars for the cassette tape ROM, and angle brackets for BASIC. So you can see in here that we do have an Apple I. It is working correctly. But our prompt is wrong. So this is a step forward. This is actually working. Now why do we have that prompt? I don't know yet. So according to all this on here, PIA enabled, yes. Yes. So something's wrong in the code in here. Don't know. I mean, I can change the PIA over, for example. And then we can reset. Yeah, see? Not good. Hit the reset again. There we go. So we are good. I don't think any of this will do anything. Yeah, so we got the thing. The problem is that anything we type is encompassed in square brackets, which was no good. Okay, so this is a bonus. This is working. We just have to figure this code out. And I will do that at a later date. So for the moment, Control A, X, yes, we'll leave Minicom. And we'll just unplug this. So this is one step forward. One giant leap for Apple I's. Okay. And that means that this tube, this is the right idea. So I had the wrong chip on the board. That's why I was having so much trouble last time. Okay. Oh, hang my solder on the solder pins over here. And, oh, there's my chip. I found the other one. Okay. So ESP. Let me go like this first. So what we're going to do is I have a VM here. Okay. This VM is kind of like my demonstration VM of stuff. Okay. So what we're going to do in here, it currently does not have the Esp IDF installed. If we go to extensions, we can look. All we have in here is the Microsoft stuff, the CircuitPython stuff, and basic C stuff. Okay. So what we're going to do in here is install ESP-IDF. And I'm just going to make my screen a little bigger up here. And a little bit down here. There we go. Okay. So, remember, this is not at my command prompt, this one, for example. This is in a VM. So, we go searching in here. Okay. And we find right there this. And we're going to actually do a full install right now. So, we install it. Give it a moment of time. Now we need to configure it. So, first of all, I highly recommend you read the documentation. So, we're going to just go over here to the built-in Chrome in the VM. This is secret stuff. You can't see this. No, actually, I don't even think it is. But anyway, there we go. Yeah. Okay, so we go here to a tab, and yeah, you can go away, and you can go away, and we paste and go. No, not that one. We want there we go. So here's the documentation link to this extension. Okay, what we need to do is follow these steps. Okay, first of all, the extension and any dependencies. So I'm going to just open another tab with that window up here. We download Visual Studio Code, we extend the extension, and we need to install the ESP-IDF Prerequisites. Okay? And then we can move on to this. So first we need prerequisites. And I believe that's a couple of packages at the command line. Okay, prerequisites. Requirements for Linux. Okay, you can see Debian, CentOS, Arch. So just basically grab this line with the little clipboard thing over here, and we go over to Mr. Bash over here, and we say paste. We don't. I'm in root, so I don't need sudo. But anyway, we need this stuff. So we install it. If you actually look at the packages, it's mostly related to C, CMake, you know, things like Bison, M4, that sort of thing, Flex. You can see that in there. So back to here, we've, oops, not that one, the browser. We need, there we go. So we've done the prerequisites. Now we have a permission issues on USB-Y. So this can be solved by adding the current user to the dialog group, or you can actually simply do UDEV rules. Okay? So if we look in our original one here, and we actually there should be in GitHub a UDEV rule file, but in here, UDEV dev rules, we have number 60 here, open CDD rules, I believe it is. This one here. Okay? This contains all the stuff. Actually, not this one. Sorry, my mistake. Where's my other one? Platform, Dev Viewer, VMware, SCSI, T-Link, Mini Pro, TTY, U2IF. Is that the one? You probably could actually get away with the USB rules, the 50 TTY, because really all you need is write access. So it's this stuff over here. So I'm just going to actually check in my VM. I should already have this rule set in here. we're just going to check here. cd etc udev rules, no less miscellany. And yes, I have the TTY USB rules. Okay, so I should be okay. I should not really need to add myself to a group, but that's basically what you're doing here. You either add yourself to the dialogue group, or you set yourself up with UDEV rules so you can write the devices. Okay, that's really what you're doing. Okay, so we're done this part. Okay, so we've done the prerequisites. We're not doing Windows subsystem for Linux 2 inside of Windows, so we can ignore that. Right? Now we want this screen. And the way you get that screen is not that. Why am I doing that? We need to run its configure program. Yes, we've done the Linux, blah blah blah, how to use install, prerequisites optional. We need to working with multiple projects. No, we need to actually do the configuration. Yeah, there it is. ESP IDF. So F1 ESP IDF install, like so. We don't need to worry about the note there. Now, when you're doing this, by default, if you pick the Express window, you're going to get the default Git tree of ESP, and the S3s won't program. Meaning it needs actually a slightly newer tree that's in there in release, but it's not for some reason being pushed as the regular release. So pick Advanced. So we're going to get it from GitHub, but we're not doing 4.3.2. Instead, we bring the window down and we do release 4.4, that release branch. Everything else can stay exactly the same. Okay? So an ES folder to store it all in, a tool folder, and of course Python 3 is our interpreter for Python. So we say install. And off to the races it goes. Yes, the horses have left the gate and they're trotting down the track backwards. Nope. Not so. But this will go to Git and download a whole pile of crap. Okay? You just have to be patient. The other thing you'll notice in here, downstairs, is we get more icons. Okay? Now I mentioned this before. So some of these icons, you can and down here, you have to be careful because they'll relate to ESPF, or since I don't have it installed here, you see there's no platform IO. I haven't installed it. You would get the platform IO strings. So in this case, in this VM, we don't have the extra set because I haven't installed platform IO. Now, if you install platform IO and then you add a ESP32 board through the project add and pick all the parts, and the framework is ESP IDF, Platform IO does exactly what this is doing, but slightly differently. It will install within the Platform IO tree. It will install a version of ESP IDF, but in their case, I think it's even less than 4.3. It might be 4.2 or 4.1 or something like that. So they're a little bit out of date compared to this version. And definitely the S3s will not compile in correctly or get installed correctly into here. So now we go and get the tools. Again, this is more this. So what you see here down the side is compilers. Okay, plus a CMake system, and the open, I believe the open OCD is similar to Adafruit's MQTT, i.e. Adafruit Connect IO page, where you go sign up on a web page and you can push web thingies over. I think that's what that is. but it's for the ESP30. It's their own system. And what happens is you end up with your own open C down there. Let me just juggle this up a little bit. You get your own version of a server that's local. Okay? And as you see, we're busy downloading. Doink, doink, doink. Ninja is a script runner. You can actually use Ninja inside of CircuitPython. It can help you generate scripts and stuff like that to do build cycles and other thing. I don't use it that way. I just let this system use it, but I don't actually specifically go and get Ninja just to use Ninja. But I know of it in Visual Studio Code itself. And Ninja also, I believe, is a Python thing. It's a Python package, I believe. Yeah, and see, you're going to run a lot of this ESP IDF stuff within a virtual environment. Now, it's very, just like Platform I/O, it is very important that you, when you're doing things in here, and you have to open a shell up, you just don't open a plain Jane Visual Studio Bash shell up. You must open a ESP IDF shell so that you have all the environment variables set correctly. Okay? Otherwise, you'll have parameters like ESP IDF path and stuff that will just be wrong. Okay? Yeah, so here we have the rules for blah, 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 blah. See the open CDS? So we're going to do this anyway. I'm just going to borrow it here. I was right about the open CD. I just didn't realize that. But we're going to do an updated version here. So we don't have a set in here. So we are going to go to, yeah. Okay, so now we have in here 60 open OCD rules. Okay, so that solves that. Now everything else is done. As they say, you can close the window. So we close the window. Okay, so we now have ESP IDF installed. Let's close that. We don't need it anymore. Okay, now you can go through the scripts, the instructions some more, and they'll talk about how to do certain things. So we've done the install, we've done all this part. Okay, the tools directory. There's an option in here, I believe you can configure the tools to where they go find them, but we don't have to do all this. It's all done for us. Okay, and by all this, you're actually done. So you can go back here to this one. So we've done install. Now we're up to basic usage. Okay. So we are going to do this, the blink example. Hey, everyone needs blink. We're going to do blink. So what you want to do here, tree. Now I want to make sure that I actually have a place to put my projects. So I'm going to go into work. Right? Now normally I have all this junk in here at the moment. So we're going to mkdir ESP IDF. Okay? And in Mr. ESP IDF, we'll just make a projects folder. Okay? Voila. Now, the basic first thing we want to do in ESP IDF to do this, we can transfer the blink example over to our projects directory. But first we have to open a folder and we actually have to go in there. Now, work and ESP and projects, like so, and we say OK. Okay, so now we have in our Explorer over here an empty thing. What now we're going to do is add the blink program. So we go back to our command palette and we find the ESP stuff. Okay, and in here you find a bunch of stuff. And what they said in the instructions, and I'll just bring it back up again, is what we need to use in this thing. So they want us to run a particular ESP or command so that we can actually do examples. And I'm just going to come here. So how to use an example, right? So what we want to do is they go up here, ESP show example projects. So here, ESP IDF show example projects. Use current home tree for the ESP, and there we go, 60 billion examples. There's our blink right there. There it is, create project using example blink. If we click that button, it'll ask us where, and we'll just put it in project. Now, do not pre-create the subdirectory. If you do that, you'll end up with blink subdirectory init blink. Okay, so we'll do that. We'll say yes to the C, and what it's asking for is about compilers. We'll say fine. We'll say allow. We'll say yes. We'll say don't show again and current folder. Okay, so now what we have here is we've copied the blink over in the template folder. This is a lot like Platform.io, where they create a folder structure with all the parts in it needed to build. Now we need, of course, an S3. Here's one. Okay. Here's the picture. So I've got one of these. Okay. Now, whoops, one more. Now, remember I told you about the two connectors on here. Those. We are going to use the top one, what they deem the Uart connector. And since these use USB 2.0 micros, we're going to put the micro on. Like so. Now, we are going to change this part here. Okay, the specified device is claimed by another driver on the host harnessing device might be in use. To continue, yes, that's fine. Okay, and we say okay, and we're just going to check here in the virtual machine that we grabbed it correctly. So we have it connected to our VM. And if we hit this button, it'll disconnect and connect to host. So we're good. We can double check this by looking at the command line. I always recommend you check. So here it is, CP201 converter detected, TTY USB 0. Now, when we created all this, it automatically created a VS Code directory and everything. Okay. Now, as I said before on the regular one, there's a issue with it finding and using the correct port all the time. So if I go to William over here on the other one, and here's the blink main, we're going to go into the .vs code directory here, and we're going to have a look at its settings file. What we're after here is idf.port. Okay, and in our VM in here, we are going to go into the settings, and you see we have nothing in there at the moment. So we're going to add one. idf.port, and it's going to come up with that is 1, and we're going to say 0. Now we're getting the red squigglies in here because I didn't put a comma up here. There we go. Okay, USB 0. Now I highly recommend right now make the workspace file here. So go file, save workspace as, and we will call this ESP32S3. Okay, and save it. Okay, if we open up, whoops, damn it, that's not what I intended. It's in the wrong folder. Let's delete it. Yes, move to trash. And did I just blink? No, I didn't. Okay, add. VS Code. No, I didn't want to add VS Code, you dummy. File close folder. Sorry, my mistake. I made an error here. Close workspace, fine, whatever. We made an error. So I'm just going to go here and fix it. ls-la cd projects cd blink cd.vs code rm-rf es workspace. I didn't want the workspace in here. So now we go file, open folder again, and we specify work. Doink. No, come on, cut it out. Damn it. Typing too quick. William, you got to stop doing that. Okay, here we go. File. Okay, so I'm just going to go file, close folder here for a sec. File, open folder. Because technically it was correct, but it's not correct. So we're going to open folder, and we're going to get this right the third time here. Work, ESP, projects, blink, open. Now we're blinking the tree over here. So our problem is I was in VS Code when I tried to make the thing. So we're going to make that workspace again. Save workspace as ESP32S3. Okay. In fact, this happens to be that plus it's D3N8R8. D3N8R8 is the variant of this one. And we'll say save. Okay. Did I just put it frickin' in there again? Yes, I did. William, you gotta stop doing that. Open folder. Let's try this again. Blink. Add. Why am I doing this? I have no idea. File, close workspace. One more time for rocket science work. cd.vs code rm-rfe doink. cd doink. We'll try this one more time. Maybe I'm not having enough tea. I don't know. Doink. Open folder. Work. Oink. 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 Okay. Okay. I don't want to be in VS Code, you stupid idiot. I want to be there. File. This time, save workspace as blink. And we call it ESP32S3 dash, what did I say? D3N8R8. D3N8R8. Okay. And we want to be in the blink subdirectory, not the VS Code subdirectory. There you go. Done. Okay. So we've modified settings at least once just to get the port in there. Now, I found that, first of all, we are in the wrong sub here, if we look. Okay? So what we want to do here is we go downstairs and we go open an IDF shell. So now we're in an IDF terminal. Okay? Now, I've noticed one thing, and I need to check in Visual Studio Code about this. Does the workspace file supersede the settings files for certain settings? If I open this one up, we have nothing in it. But here, we have these two things in it. And even so, in this one, we have 4 things in it. Okay? So what we're going to do is first, I'm going to set the target here. And we are going to be using the ESP programmer. So we pick that one. And we assign it. Notice it how it adds a bunch of lines to here. Okay. Now the other thing I added on my other one over here, no, not in here. I was adding the speed and how fast you can do it. So if you were to go here, I think something like this, and you were to IDF dot we want speed. Is it in here? Or is upload in here? Okay. There is a way of doing this. It occurs in the platform IO. You can actually specify faster speed for these. But anyway, now this whole blob in here, right? It says USB down here 0. It says USB 0 here. But there's a chance when I build this, it'll try to write to 1. So we can go down here to the trash can. Now, when you copy this over, it puts a build tree in here. It might not work. So you can try it, or you can clean it right away, which I'm going to do, and then build again. So there it's building. It generates the different sections of what you need. Probably the program, the bootloader, a bunch of stuff like that. It's, in fact, if you actually look at any of the ESP stuff on Adafruit, it's the same way. But they have this particular bin file called combined, and this is what this is. So here's our thing. It built it. Now, if we hit the lightning bolt here, flash the device. Let's flash. And I will use Uart. Now we have a problem. See, there's errors in here. If we look at our errors in here, let's just block up there. USB 1. No, I have it on USB 0. Why is it doing that? So I found that if I take this block of code in here, copy, and I go to here under settings. Okay, so in settings, now I'm a one to line up my brackets, of course, right? Now what we have here is a slight problem. I have a square bracket and a round thingy, so I need to just go back. Where was the other square bracket? Okay, that was on that one. Okay, so I know this right here, and I'll do this. And then we have a squiggly out of phase here. So that closes that. That closes that. I don't think we need the second set of squigglies. I'm just going to mash the lines. Whoops. Like so. You know, good old JSON getting this right is... here we are. Okay. There we go. So we have settings, and in settings we have this. So just like this block. We go Control S on this file also. Okay. Now let's go here and just Control L this. And let's see if we can upload again. Better. See, it's now saying USB 0, but we're not getting in the great crap. Okay, so what we have to do here is just rebuild. So I'm going to trash can it again here, and then build the project again. Once you got the pattern figured out, you can then basically do any of your boards. Funky cable. There we go. So we're building the bootloader, generating all the sections. There we go. So let's try the lightning bolt again. There we go. Upload. successful. It's on USB 00. This is the issue. So don't know why. Somewhere it's coming up with USB 1 unless you make a workspace file and clone the settings file into the workspace file. But that's it. So I just wrote a Blink their Blink program into here. I don't understand the Blink program yet because the code is a bit weird. And the second problem I'm having with this is it's not figuring out any of this. So this is not ESP IDF's problem right here. This is all Visual Studio Code not tracking down where headers are. So I know on CircuitPython I simply had to add some more paths to my settings or my workspace file to find things, and I suspect I'll have to do the same thing in here. Okay, so in here this path thing has to be updated. So not only do we have to look here, but I'm pretty sure we have to look on the ESP IDF path also to find stuff. And I think it's not finding it. Now, according to them, this is what's supposed to happen. Okay? So compiler path, for example, include path. See this stuff shit right here? This particular expression, right? That's the Linux one. Problem is, it's not finding it. It's like it's not expanding these variables properly, and I'm not sure exactly why. So I could probably get around by putting home wilm ESP IDF. If we go down here into the terminal and we say set actually grep for ESP. There. See IDF path right here? This right here. Okay. You know, we could add this in. It's like not really a big effort. So we can go like this and we say doink and we say doink and we say components. Yeah, I think that's it. 1x /* like so, comma. Okay, so that's the ESP IDF path. See, this is really stupid. Why are you putting two sets of them in? So we have config IDF ESP IDF path, config IDF ESP IDF path. Then we have the browse one. So let me just check where's the browse one taking it. Components also. So if we take this line here and borrow it, Control C, and we go here, and they have that one and this one here like so. Control S, and we could check and see if we solve Control S to see if it refreshes properly. Nope, not quite right. Now there was another one in here. Where was it? I don't know if they put it in. Yeah, the tag parser right here. This is supposed to help the IntelliSense find things. Okay, but I'm pretty sure if you were to go like this, Control C and Enter V, and go into here, we got this one too. And if we go like this, we go Control S. That fixed that, but introduced two more, right? So it's complaining about two, but it's fixed the path. Okay, So what is the 2 that's complaining about? Config blink period is undefined. So where is blink period? Usually when you start seeing grayed out stuff like this, it's having trouble with code. Right here, config blink period. So VTask delay, config blink period, doesn't know where this is. Port tick period, doesn't know where that is. Functions, functions, functions. But we solved one issue and broke another issue. So technically we've solved the include problem here. But we've added in include could not find requested file. Yeah, that's fine. I'm told this particular warning here is because you only get the path for the CMake file when CMake actually runs. It doesn't actually show up in here, so you're always going to get an orange on here. Okay, so VTask delay, is that our function or their function? App main, configure LED, blink LED, configure LED, blink LED. I don't see a VTask thing. I would have to now look up some of the code here, the API, and find out what's going on. But I do know it generally works because I have a blinking light down here. So, but it does push and everything. This is a better breakdown of my last video on how to install this. So this environment is all ready to go to work ESPs. And you should be able to, from here, for example, pick any of the ESPs. So this is an original ESP32. This is an S2 version, S3 versions, and C3 versions. Okay, they're all in here. Now you can, if you're just doing S2s and originals, you can go back to Platform IO, for example, and use theirs. Use their system to do it. But yep, that should cut it. If you need me to break down this, oh, I know what I could talk about too. There was a question about someone not having missing parts in CircuitPython. So there was a thing, and I commented about this. And it's going to bring the comment up. So in this case here, I'm going to, now since there's no storage on thing, I'm just going to disconnect this S3. It doesn't matter, right? This code and everything like this is not like CircuitPython. It's not on the ESP32. It's actually on your hard drive. So we can safely close this workspace like so. And in this case, virtual machine, I'm going to suspend it because I don't need it anymore. Yes. Okay. And so I don't blow that file up. I'll get out of it. That comes back to my core Visual Studio. I'll put this in the box because we don't want to damage the thing. And put the lid on. And put it away. Okay. So I had one person who was having trouble with the CircuitPython. So in here, I have more extensions than I showed in the chat, but fundamentally the basic stuff in here is you'll want the CC plus IntelliSense stuff, i.e. this pack right there. You'll want, you can throw the extension pack in. All it does is put all these in. I added snippets and themes myself because I was messing around with look and feel. Here's the other this is an IntelliSense to help with GNU global tags, but not important. You don't need this. You don't need the Chrome Dynamics. But when you put CircuitPython in, it'll actually make use of two other Python pieces plus main Python, and that is Magic Python and Pylance. So you put this in, you're going to put this in, and you're going to put in, of course, Magic Python. Magic Python is the syntax highlighter and stuff for Python, and Pylance is telling you where you screwed up. This is the language server that Microsoft uses in replacement of Jupyter, which is the other language server that they used to use. Okay? So once you have all those in, and you install CircuitPython, and he's gotten this pretty good. So the trick is here, and I'm going to just find myself a little feather board here that we can plug in. Not that, that's a maker board. So I'll find my little pink one, and we'll install this. Sorry, I mean we'll plug it in. Okay. We'll get a pop up here in a moment. There. To let you know, it's the bottom CircuitPy. The top one is my macro pad. So I've mounted this particular CircuitPy. There we go. And now I go up to here and I go and open a workspace. Go to that CircuitPy and I'll open up the feather one. Okay. I haven't opened up this in a few days. So you can see downloading bundle, and I'll just squeeze this up higher a little bit. Downloading bundle. Note the date, 22/01/10. Okay. Note over here, it's not resolving stuff. Okay. Code has a yellow on it. So go to JSONs. I need to change this from 21 to 22/01/10, and this one too, 2/01/10. For some reason this one does not get updated, but the workplace one does sometimes. In this case, it's also not getting updated. So you fix this one in here too. 2/01/10. I need to submit a bug ticket about this. Sometimes I see this one updating properly and the other one not updating properly. Okay. So as remember from the ESP-IDF, these lines are the same lines that are in settings. See? Blah. Okay. Also, we're not CircuitPython 7.0 anymore. We're 7.1, I think, on this guy. See, this part updated. Okay, so that's basically what he was running into, is that he wasn't seeing these two. Now, if CircuitPython and Pylance and Magic and Python are all installed properly, right? As soon as you plug this board in and mount the drive and then go open that drive, this stuff starts getting created. It begins with the settings file. It starts populating the settings file. And then when you save the workspace onto the drive on here, then the workspace file, of course, gets created and its entries get put in, i.e. all this stuff. So folders, paths, settings, right? Da-da-da-da-da. Like so. Now, this helps figure out the board pins. So these guys are just, they're the product IDs. You can see these numbers, 239A and 80F2, if you demessage after you plug the board in, right? And you go and look at the Raspberry Pi, you find when it plugs in, so 32370. If we look, it's around here somewhere. RP2040 keyboard, 24 mouse. RP2040, there we go. There we go. ID vendor 2390A product 080F2. Kind of looks familiar, right? So it gets these things and uses it to figure out the boards. So stubs figure out where code is, boards figure out where pins are. So which of all these pins on here are mapped out, how they're mapped out. Okay? So we don't really need these files anymore, and we can now actually go back to Mr. Code here. So I happen to have a NeoPixel blink testing thing in here, so I was messing around with NeoPixel and those Christmas lights at the time. Okay? Now it is important, if you want the workspace file to populate properly, that you pick a board down here. Make sure you pick a board. Okay? Also make sure your language mode is set to Magic Python. So the type of Python syntaxing you want, the board you want, and this guy here opens the serial monitor. And just checking notes to find out what the date is of the bundle of the day you plug all this in, because this changes on a regular basis. Okay? Now, if you want to make sure that your libs are up to date, you do not have to do this as root, but you do have to have CircuitPython, CircuitPy, the directory mounted. If I do a df here, it's right there. Okay? CircuitPy. So there's a tool you can install called circ up. Okay? And if you press enter, you'll get to some short options you can do. What we care about is update -- all. So it's checking, getting a new bundle, and it's checking if any of the libs in this thing need updating. It will also tell us what's running on it. But there is a secondary way of looking at those running things. If we go back here and we look at bootout.txt, and I'm going to open it with Notepad. So right there, you can tell what version of 710, when it came out for this one, blah blah blah. Okay? That's two different ways of doing it. Now, if you update this to 720, for example, when 720 comes out and is released, and you update this by doing the UF2 install, which is, well, you unmount the CircuitPy, and then you double click the button here on the thing right there. You double click it and it goes into RPI boot or something like that. You mount that directory. Okay? Then you go and get your UF2 file. In this case it would be 7.2 UF2, and you drop it in place on that drive and it updates it. But in that case, what will have to happen over here, Control Alt pip, Control R, you want to do this command, because circup is tied in a sense to the version of the thing that is installed. So we can do this right now. Yes, there's a newer one. Okay, so it updates things. Okay, and we can do this just to double check to make sure it's still working. There we go. Okay, if you get a message from here where it can't get the bundle, as seen before when it went and got the bundle right here, then this circup is out of date. In Python on this side, always make sure that you've done that one, or you've done this one. Okay, that you've updated the pip installer. This changes also on a regular basis. So you'll get a red warning about your pip being out of whack. So these are the two commands to remember to do. Pip3 install, or it doesn't have to be pip3. It can be. It depends on your system. You might have strictly Python 3, then pip is actually mapped out to pip3, and that also works. See, like so. You can see it's doing exactly the same thing here. Okay. Now notice too, it is actually updating pip in here in your home tree in a place. Okay. There is your Python install local to you, and then there's the Python install local to the system. Basically, Python wants you to stop screwing around with the system ones, unless you dire need a global package installed. Instead, they want you to do the your local one. And the reason we're getting this here in the Express Python environment, blah 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 setup, is because I believe I have the environment set to IDF at the moment in this window. So grep ESP. Yeah, see all this here. Now if I go to another will.m, let's find another one here and see if I got it in this one. No. So if I go Control R pip, Control R, that one. Now we're doing the one in local lib Python 3.8. The other window was actually an ESP shell in a sense because I had all the variables started. It doesn't really matter as long as I can find it, right? And the circ up in here, if we do circ up, oh, no, it's not upgrade, it's install -- upgrade. Whoops. I think it was. I can never remember. Pip control mu editor pillow upgrade pip. Nah, that's not the right one. I think we're actually current because we're at 103. Update -- all. We'll know if this blows up. Yeah, that's fine. We can actually -- version. Yeah, okay, we're at 103. That's fine. Okay, but you get the idea. So if you're having any issue with the extension for CircuitPython in Visual Studio Code, make sure you have those extensions installed. Make sure that you open the folder after you mount the CircuitPy drive. Right? Don't make the assumption that you're just going to automatically start doing CircuitPython without doing that, because all these microcontrollers have a drive on them. Right? So even the macro pad. Okay? So let's dismount for just for a sec here. I'm going to close this workspace here, and I'm going to exit this CircuitPython, safely remove, and I will mount the other one. And we'll open it up. That's the macro pad over there. Okay. If we go and open workspace from file, CircuitPy, macro pad number 2. Okay. This has been updated. Now I have yellow over here. So I need to go into settings here. Now you can manually type this or go Control H and find 2021-12-02 and change it to 2022-01-10 and replace all. Okay, Control S, save that one. Okay, now you can go to this guy here, and you remember I told you about it sometimes doesn't, some this one case it did. It updated this one already, so we don't need that. But there's the macro pad all ready to go. All the codes are done. Okay, And so the main code is down here. Now I took this strictly from the sample thing, so even though code.py is the one, these other ones are the same file, but they're just renamed to demonstrate what they are. So Firefox, Media, Mouse, Numpad, OBS, Tones, right? That sort of thing. Boot out. Okay. Now this code file in here, I suspect doesn't belong. I was probably messing around. Let's just go and close all these editors off. And if we look inside of this CodePy, this is the actual thing. The macros is where you define all the macros. Actually, it might be correct. I don't know this side enough. Yeah, so this guy here is the macro, and I don't think it was supposed to be called code.py. I should have called it obs.py. Right? This should have been like that. And then in here, at the very top, where you call the macro in question that you want to use, macros, blah, blah, name macros, blah, blah. There's in here a place where you list the macro you're going to call. Macro folders, ends with .py. No macro files found. That's the test. Now it's cycling through all of them. Now there was a place in here where you could actually define which specific macro you wanted. Okay. Now I don't want to mess with my macro pad because right now it's controlling the record buttons and stuff. So I will get that in. I will fix this up so that it actually only calls one macro pad. Yeah, I think right now it's stuck on Firefox because it's in technically I think in alphabetical order. I think if you rotate the little wheel on the top, yeah. There you go. Now I'm OBS scene 2 by just turning the encoder wheel. Now I can also go here. Let's just close this off before I break something again. We'll close the workspace off. I can now go to here and circ up update -- all. So it's telling me in green that there is a new CircuitPython here, 7.1, and it's actually updating some of the stuff in here. Now I think the button for this is on the side, if I remember correctly. Yeah, it's actually right here. As I said, I don't really want to mess with that until I take it offline. But yeah, so that's CircuitPython and a bit of troubleshooting if you're having issues with it working at all properly in Visual Studio Code. You probably missed the extensions, you probably missed mounting the drive, and once you mount the drive you should be able to see all those types of files and it should just work. Now the guy Joe has done a pretty good job. He just needs to fix the quirk with the settings file not updating the date. But in essence, I think what he should really be doing, he should be symbolically linking that directory so that the settings file just has a thing it fills in, but in reality at the drive level his code would map out a new symbolic link to that date and just plug it in, right? So we will. I was going to suggest that to him. You might want to do it that way. That way you never have to worry within Visual Studio Code about that date parameter, right? We should kind of hard code some JSON files, and you shouldn't be doing that anyway. Not that way anyway. So that's it for tonight. I hope this helps people with both the ESP and the CircuitPython and know that I got my Apple one kind of working. Kind of. So next step is to figure out the Apple one. So good night for tonight.